Hello and welcome back to KHW4.3, the answer key. Let's see. 24 divided by 12 is 2 times 2 to the 7 equals 14. Oh yeah, they're both equal to, well, not quite a half. More than a half. 1/12 more than a half, both. So A equals 14. Let's see. Now this is interesting. I'm trying to get here, so I need to figure out how to get here from here. How do you get to the 7 from a 21? Well, take 7 divided by 21. That's 1/3. 1/3 of 18 is 6. And you can check it out. This side is 6 times 3 is 18. 7 times 3 is 21. So this is still the ratio of 6 to 7. It's just that the top number is blown up 3 times bigger and the bottom number is blown up 3 times bigger. But if you had almost as much Pokemon cards as your friend, you had 6 Pokemon cards and they had 7, then you have 6/7 of what they had. Now if you both grow your collection 3 times bigger, now you'll have 18, and if they grow theirs by 3 times bigger, they'll have 21. You still have 6/7 of what they have. It's just that you both have more. But the ratio, the comparison, is still 6 to 7. And that's what similarity is all about. Similarity thrives on comparison because the comparisons stay true. Now that's actually really strong because now whether you have a tiny little triangle like on a blueprint, tiny little triangle on a piece of paper, versus a giant triangle on a bridge, the comparisons still are true. Even though the triangles are different sizes. Alright, let's keep going. So it's going to get tricky here. Trying to get here. So what is 9 divided by 6? Equals 3 plus 6 over 6. That's 3/6 plus 6 over 6. That's 1/2 plus 1. That's 1.5. And 10 times 1.5 is 15. So there's different ways to, some students just do this, some people circle it, some write C equals 15, they're all fine, as long as you got the number and understand what's going on. Ooh, how do we get over here? Well, it's the same way that we get over here. How do we get from here to here? Well, what's 2 divided by 20? That's 1/10. So what's 1/10 of 13? It is 1.3. And you can find these things in a calculator. 1/10 times 13. You can type 13 divided by 10 equals 1.3. Okay, we're doubling. So what doubles up to 2.5 doubles up to 5. So this is 2.5, but what's B? Well, there's already a 2 sitting there, so B must be 0.5. Oops, that was annoying. Let's do it again from the other perspective. Let's say we're trying to get here. How do we get here? We divide it in half. What's half of 5? 2.5. But this expression here has to be equal to 2.5, so what does the B have to be? I think we said skip this one. I believe C is the square root of 4. But we haven't really done roots this year. Whatever. How do we get here? Well, how do we get here? Well, it's the same way that we get here. How do we get here? Well, let's go backwards with division. What's 20 divided by 4? That's 5. So 4 times 5 is 20. Checks out. 3 times 5, since 5 is the multiplier here. Man, start over again. Sorry, I'm in a different space today. This is my window. This is not my house. My computer's over on the far left, so I keep on not looking at it. Anyway, the answer's 15. Let's move on. Times 5 is what we need. So now 15 equals B plus 3. b equals 12. Ooh, fun. How do we get here? It's the same way we get here. How do we get here? Well, let's go backwards with division. 8 divided by 3. And then take, so look at this. 3 times the scale factor 8/3 equals 3's cancel 8, which is what we get. So 8/3 is the scale factor. 6 times the scale factor of 8/3. How did I find the scale factor again? Well, I need to get to an 8 from a 3, so I just divided 8 by 3. Now usually we get a cool number like 2 or a half or 1/3, but here we just get 8/3. But that still works. This is a little more annoying. So the way I would have done this is 6 times 8 is 48, and then divide by 3. What's that, like 16 or something? But since I started teaching math, it is way less work to rewrite 6 as 2 times 3. And then if you're multiplying by 3 but then later dividing by 3, those cancel, and 2 times 18, or sorry, 2 times 8 is 16. So this is 16. I haven't shown you using just old-fashioned algebra. Half of 6 periods thing for the rescue. Let's just do this funky one. You just multiply by both denominators. So first let's multiply by 20, and we get 20a, 20 times a on top, divided by 2, equals, that cancels and you get 13. Then multiply by 2 and multiply by 2, and you get 2 times 2, 20a on top is 40a, divided by 2, still, no, that's what we just got rid of. So just 40a equals 26 divided by 40, and a equals 26 40ths. Did I screw this up? Is this a different answer than the other one? Is it a different problem? I got 1.3 last time. What did I do wrong? Oh, right here. I actually multiplied 2 times 20a, but I was doing that to cancel this, so the answer is just 20a. There we go. Okay, and then 26 over 20 is the same as 13 over 10. 13 over 10 is 1.3. So that's why people don't like to do the long algebra way, because you could make a mistake. Okay, let's do it one more time though. Ooh, because there's C on the bottom. This is fun. Times C times C. 9 equals 6c over 10. And here we can multiply by 10/6. The 6 on top cancels with that one. The 10 on the bottom cancels with that one. And all we got is C. Oh, we got to do it on the other side. This is algebra after all. Whatever you do to one side, you got to do the other. 96. Is that right? What is 96? I feel like I made a mistake again on this one. Where's the 9 over C one here? 15. That checks out. Yeah, because 60 would be 10, there's 30 left over. I should get a calculator. Hey Google, what is 90 divided by 6?
90 divided by 6 is 15.
Alright, we got it. Man, I guess... Okay, let's get this done with. All right triangles are similar. No. And we need a counterexample. Here's a counterexample. That is an angle of 30, 90 and 30, and here's one. 90 and 80. And I guess this would be 60, but this would be 10. Okay, we do not have two angles that are the same. So we need two angles to be the same in a triangle. For them to be similar, so all right triangles are not similar. Any two right triangles with one other angle that matches. Now that's two angles, the 90 and the other one. But that's not all of them. But that is a cool way to get to. All regular polygons are similar to other regular polygons with the same number of sides. That's critical. Because obviously all regular polygons are not similar to all other regular polygons, but all regular polygons are similar to other regular polygons with the same number of sides. Why? Because all the sides are the same length, so they're all in a 1-to-1 ratio, no matter how big they grow. And all the angles of a regular polygon are always the same, no matter how big or small. Why did I draw an octagon? Prove this. No. I mean, I can't prove it, but I can prove it wrong. Watch this. If you take mn and then divide it by lm, it is not proportional to m prime n prime divided by l prime m prime. And if this was just a shrunken down version, that comparison would hold true. But it is not. It is 2 diagonal here, or these 2 divided by 2 diagonal versus 1 divided by 2 diagonal. 2 divided by 2 diagonal does not equal 1 divided by 2 diagonal. So I know this is a non-standard math notation, but I'm going to move on. Prove these are the similar. I'm going to prove it through proportions. This is going to be, gk divided by g prime k prime is the same as kj divided by k prime j prime is the same as ji divided by j prime I prime equals, what's the last one? ig divided by I prime g prime. Now some of these, the diagonal ones, well, we're going to have to do at least one. kj, kg, gk is by the Pythagorean theorem, 2 squared times 2 squared, or sorry, 2 squared plus 2 squared equals c squared. This is 2 squared is 4, 2 squared is 4. Let me just write this out. That side's 2 plus this side's 2 equals c squared. So we're figuring out what that is. This is 4 plus 4. This is 8. So that's the square root of 8. This is 1 squared plus 1 squared, which is the square root of 2. So that's the little one. So gk is the square root of 8. Now I have to show you something about the square root of 8. Actually, I don't have to show you. Well, yeah, I do. The square root of 8 can be rewritten as the square root of 4 times 2, because 4 times 2 is 8. But this part of the number we can actually square root. What's the square root of 4? 2. 2 times 2 is 4. What did we not get out? 2. So this is another way to write the square root of 8. It's 2 times the square root of 2. But now, when we put it in our proportion, we're writing 2 root 2 in the bottom, and then g prime k prime is just the square root of 2. But now this cancels, and we get 2. So the scale factor better be 2. Let's check the only other one that's a straight line. So this is 3. Where's ji? 3 over 1.5 equals 2. Secant factor is 2. So we could do the rest with all, we could do it with all of them, but no thank you. Oh. This one can be done in one move. Reflect over this line. This one I'm going to take m to m prime, translate m to m prime, rotate. You could take any of these points to any of their matchy points, then rotate until mk coincides with m prime k prime. So if we move it over there and then this lines up, you can kind of see this shape will be sticking out like this. So then we have to reflect over this line, which is k prime, m prime. So reflect over m, k prime, or m, the line segment. Actually, reflections occur over entire lines, whether you want them to or not. So there we go. And if you, let's say you took h to h prime, then rotated until hi is on hi prime. Sorry. Let's say you took e to e prime, and then rotated until eh prime is on eh, and then reflected over it. I mean, you could have taken any point to any point, then lined up with any of the two lines next to that point, and then reflected over them, and it would work every time. B prime prime? What the heck? Dink. And then it looks like they're already going to be, let's say it anyway, rotate until BD, set the segment, coincides with B prime D prime, the segment. In fact, I forgot to write those up here. The segment, the segment. And then we need to reflect. Yeah, we need to reflect. And then reflect over BD. Let's go with the double prime thing. Yeah, why is it double prime? Reflect of. Man, I am distracted. I usually record these in the morning. I feel like I'm sharper then. Okay, this will be easier. This one needs a dilation. What's the scale factor? Looks like it's going to be 2. How can I tell? This is down 4 over 1, and this is over 8 down 2. So let's rotate it first. Rotate around point A, nope, just clockwise. Well, whatever, counterclockwise, I don't care. Until AC prime prime coincides with AC. Dilate around point A times 2. No, it's the big one is trying to get to the small one, so it's times a half. The small one is the image. It starts with this one, so it needs to swing over and then shrink up. Proportional. All corresponding triangles. Congruent. Determine whether or not the pairs of triangles are similar in Y. Yes. A. Is 8 over 22 equal to 4 over 12 equal to 3 over 9? Aha! This equals 1/3. This equals 1. I'm not even on there. Okay, 8 over 22, 4 over 12. So 8 over 22, corresponding, 3 over 9. That's 1/3, that's 1/3. This is not 1/3. No. Sides, not proportion. No. Yes. Ah! I didn't slide down again. This is a terrible setup. It was really storming out there. I don't know if you can see the... You cannot see the rain.